I'm going to return this in a tuple. Tuples could not be simpler syntax, just open parentheses, not 9, open parentheses, and then just all the types that of things you want in here. So I'm going to return a double question mark. That's my result. Okay, that's what's eventually going to be returned out here after all the recursion unwinds. And then also, I'm going to have the ops that are left over. Now, a tuple can look just like this, unnamed. You see how these things are not named, each of these things in here? But you can also put names in here if you want as well. So maybe I would call this one the result, okay? And I would call this one remaining ops, okay? And I kind of recommend putting those in there, and you'll see why in a second, because there's two ways to call a function that returns a tuple and get the results. And one of the ways requires that you name these, okay? So it doesn't hurt to name them. You might as well. It's good documentation. Someone looking at this now knows, oh yeah, this is the result of the evaluation, and this is the ops that were left over. Okay? All right. So let's dive in here. The first line of code I'm going to put in this recursive function is the failure line of code, which is return nil ops. Okay? So if I fail, okay, I'm going to try and do my best in here to evaluate these ops you passed me. But if I fail, I'm just going to return my result of nil. Okay? And that's going to be my default, is to return nil. So now I know I failed. So if I run out of operands or I run out of stack, can't find it, for example, it's just going to fall out here and return nil. Okay? So that's good. So what do I need to do here? Well, first thing is I need to make sure I have some ops. So I'm going to check to see if the ops is not empty. Okay? If you've handed me a stack of no ops to evaluate, I can't do that. So I'm just going to return nil. Okay? So that's the very first thing. I got to make sure I have some ops to work with. Now I'm going to grab the first op off the stack. So in this example, I'm going to grab that x off of here. Okay? I'm going to do that. I'm going to try to do that by saying let op equal ops. Okay? Ops is this argument right here. Okay? That's the ops you told me to work on. And we know how to remove last. Remember removed last from last time? Removes the last thing off an array. And when we are trying to make an array look like a stack, that's how we do it. Okay? We push things by putting things on the end of the array. We pop things by pulling it out. But you can see I got an error there. And it's very important to understand why I have an error here. Okay? So I'm going to click on it. We're going to read what it says. It says immutable value of type array of op only has a mutating member named remove last. Okay, well this is kind of a formal way of saying you can't do remove last on ops because ops is immutable. It's read only. You cannot mutate it. You cannot change it. Okay, why is ops read only? Well, there's two things to think about here. One is when you pass arguments into functions, unless it's a class that you're passing, unless you're passing an instance of a class, the thing you pass is copied. Okay? It's very important to understand that. That's passed by value. You're used to it in other languages. Most languages do this. Passed by value. Arrays and dictionaries are not classes. They're not classes in Swift. They're structs, you know, like a C struct. Okay? Arrays and dictionaries are structs. Structs in Swift look a lot like classes. They have functions. They can even have properties that have storage. They're almost identical to a class, really. The only two huge differences between structs and classes, one is that classes can have inheritance and structs cannot. Okay? But number two is that structs are passed by value and classes are passed by reference. Okay? Very important that you understand that distinction. So structs are usually only used for basic, you know, components like arrays and dictionaries. Even doubles and ints are structs in Swift. Okay? And that's great because that means doubles and ints can have functions on them and things like that, which we'll see as the quarter goes by. But those things are all passed by value. So that's the first thing to understand is that this ops, when I call evaluate, whatever array of ops I pass to it is going to be copied. Okay? The second thing to understand here is that there's kind of an implicit let in front of all things you pass. In other words, they're read-only. Make sense? And a read-only array can't be mutated. You can't append things to it. You can't remove things from it because it's read-only. Now, I can actually put the word var here. Okay? If I put the word var here, then ops inside here, look, no error. Ops is a mutable array. It's still a copy, though. So they copied it and made it mutable. And now, inside here, I have a mutable copy to work with. Now, I'm not a big fan of doing that, okay, of putting var up here. I think it's a little confusing for readers of the code to understand exactly what's going on there. So I'm not going to do that. Instead, I'm going to make a local variable here, which I'm going to call remaining ops. And I'm going to set it equal to ops. Now, when you set equals like this, that copies it if it's not a class. Classes are all by reference, exactly what you would think. But anything else, structs or enums or anything else, when you do equals here, this is actually going to make a copy of this and put it in here. And since it's a var, it's going to be mutable. Okay? So now I have a mutable array of ops, and now I can say remaining ops, remove the last one. And now I truly do have the remaining ops. I've removed the first thing in there. Okay, everyone understand that little tidbit there? Yeah.
So there's like a unseen let in front of the ops.
Yeah.
Like, why isn't that let in front of doubles and like ints or strings?
It is. So the question is, why is there not kind of an unseen let in front of all arguments? Pretty much all arguments to functions kind of have that unseen let in there. They're all read-only. Okay? So, and you could put var in front of any one and turn it into a mutable copy of it that you could use locally. But you can only use it locally. It's not that great a thing. Okay? Now, there is a way to pass by value things back out, but I'm not even going to talk about that. Okay? You can read about it. It's this in-out thing. I'm not even going to talk about it. I really think it's better to stay within the value, pass by value and pass by reference parameters. I think we get more readable code that way. But there is a way I'm not going to talk about to do in-out, basically, parameters that go in-out. Yeah.
Is there any way to pass by reference? Because if on squared huge array, we just copied it 3 times.
Yeah, that's what I've just said. There is a way to pass it kind of by reference, in-out. You know, you pass it in, you modify it, and then it'll come back out when it's done at the end. So it's kind of like by reference. But the other thing you said is, oh, this is terrible. I'm making 3 copies of that dang thing. This must be super slow. And the answer is no. Swift is super smart about not actually copying it until you actually make a change to it. So here, when it passes a copy in, it didn't really copy it. It just kind of passed a pointer in, but it knows that pointer is by, not by reference, is by value. And then when I copied it again here, it still didn't really copy it. Even if this array had a 10,000 things in it, it didn't make 10,000 copy of it. It was only here where I actually mutate it. Now it had to make a copy. And it may not even have made an entire copy. It might have just kept track of the changes, for example. So it's super smart behind the scenes. Swift is very smart. So don't worry too much about, oh, I'm copying these things over and over. Swift is making the minimum amount of actual copying going on. Okay? All right, so now I have remaining ops here, which truly are my remaining ops, okay? Because I've removed the top one, the x, off the top. So now I've got all the remaining ops in this local variable here called remaining ops. Okay, now what am I going to do with this op that I pulled off, this one on the top, the x? Well, I'm going to get the associated value from the enum, okay, either this or these or this. And how do I do that? I use switch. Okay, I told you that switch is really important, and now you're seeing that switch is really important. Switch is how you pull things out, associated values out of enums. So I'm just going to switch on the op. Okay, this is the op that I pulled off the top, that x from the thing we did on the board. And I'm just going to look at all the cases. So I have a case operand. Okay, notice that it puts a little dot here because it's really op.operand, and it's using type inference to know that it's op.operand, right? It's op.operand, but it doesn't need the op there. And here it's asking, in this space, what do you want to do with the associated value if you're handling this case where the enum is operand? Okay? Well, I want to let that associated value be assigned to a constant called operand. Okay? And yes, I could put var here, which would do the same thing, except for I could then change that thing in here, but I almost never want to do this, almost always let. So let operand means that inside the handling of this case, okay, this case of the switch, inside here, operand is going to have the associated value of the operand. Okay? Ooh, that's exactly what I want. I'm just going to return. Right now, I have to return this tuple right here. So I'm going to return the operand. That's the result. Okay? When I go here and I encounter that next one down, which was a 4, I got a 4. I can just return that result to evaluate this one. And I also, though, have to return the remaining ops. Okay? So I'm just returning the 2 values of this tuple. Notice I don't have to put result colon and remaining ops colon in here. It knows that those match, and so it's just doing it. All right? Make sense? And that's it for operand. That's all I have to do. It's kind of, in the recursion, it's kind of an end case. Yeah?
Is remaining ops stored on the stack or heap?
This one here or this one here?
Well, in general, are Swift structs like class?
Okay, so the question is, when I do something like this, where is remaining ops? Is it in the heap? Is it on the stack? And the thing is, that's implementation detail. So you don't know, but you don't care. All right, so that's operand. Operand was really, really easy. How about our operation? Let's do unary operation right here. Now, when we handle the case of the unary operation, we don't need that first associated value. That's the symbol, like plus. Okay, well, I'm evaluating here. I don't care what the symbol is. I only care what the function is, because I'm going to evaluate the function. So we can actually ignore this by putting an underbar. Okay, underbar in Swift is kind of the universal, I don't care about this thing. Okay, and we're going to see it other places we use it where it's kind of like, I don't really care about that. So you just put an underbar there. That way you don't have to declare a variable with some dumb name or something like that. Just put an underbar, it ignores it. Okay, but I do care about this. I'm going to let that equal the operation that I'm doing. Okay, everyone make sense there? So I'm ignoring the string, but I'm grabbing the operation. So here, what I want to do is return, and I'll try to do it, but I'm not going to be able to. I'm going to say return this operation with its operand, which I don't have, and some remaining ops that are left over after I get its operand. So I need to do some stuff here to be able to return what I want. The first thing I need to do is get the operand. Okay, so I did a unary operation. Let's say it was square root. I need to go back to the stack and pick off the next thing, but I can't just assume that it's a number. It might be more operations, so I have to recurse. So here's where the recursion comes in. And now I'm going to show you how to call a function that returns a tuple and get its value out. So this is an important little example here. So there's 2 ways to do it. I'm going to do it one way here, which is I'm going to let operand evaluation, which is just a local variable that I'm inventing, equal call evaluate with the remaining ops that I have. Okay, so here I've recursed. Okay, I'm recursing. And I just set it to operand evaluation. Now, let's look at the type of this thing. If I look at its type, you can see that it's a tuple. That's its type. It's a tuple, result, remaining ops. It's this tuple right here. That is the type of this operand evaluation. So now that I have that tuple, it's the result of evaluation. How do I get the result and the remaining ops out of it? Well, I can get the operand by saying operand evaluation dot result. Okay? So that just this is the tuple. Here I'm getting this value of the tuple out of there. Now what type is this? Anybody? It's an optional. You're pretty safe saying optional when I ask what type it is, aren't you? It's almost always an optional, because I usually don't ask if it's not. But it is indeed an optional double. It's this type right here. Okay? So we need to turn it into a double if we're going to pass it to this operation right here. So I'm going to use if let to turn that into a double. Okay? Now I can actually do this because I have the operand. Just got it right here. Okay, this is now a double, see? And I can call this operation right here. And this is the remaining ops, but this has got to be the remaining ops after we recursed. So it's got to be the remaining ops in this operand evaluation. So that's operand evaluation dot remaining ops. Everybody cool with that? So that's it. Let's just recurse. We just recursed to evaluate that. If this fails, if this recursion returned nil, then if let's not going to happen, this return is not going to happen. We're going to fall all the way out and return nil, which is what we want. Okay? If we fail in any of our recursive attempts to get the operands we need, we got to fail all the way up to the top level. Okay, now binary operation. Also, okay, let's do, binary here, case, binary. Obviously, same exact thing here. We don't care about that. And here we're going to let operation. And we're going to do exactly the same thing we did here, but we just have to do it twice because we got two operands to do through here. So let's let our op1 evaluation equal evaluate with our remaining ops. Okay? And then if we can let operand 1 equal the op1 evaluation result, okay, then we got op1, that's good. So now let's let op2 evaluation equal recurse again with op1's remaining ops. Okay? And if we can let operand, if we can let operand 2 equal op2's evaluation result, then we can return a tuple which is calling the operation with the two operands. Okay? And we'll have op2's evaluation remaining ops as our remaining ops. Okay? Make sense? All right, we got an error here, what is it? Okay, yeah, so this is a good error to cover here. See, this says method must be declared private because its parameter uses a private value. And sure enough, op is private, so this has to be private. Okay? Now notice, by the way, I don't have default : break here in this switch. And why do I not have that? Because I've handled every possible value of op. Okay? There are only 3 kinds of op. I've handled them all, so I don't need any default. It wasn't like in the other one where we had a string. We only handled a few strings. We had a default break. You don't put default break in when you handle everything. And it's really bad programming style to put a default break in every single switch. Okay? You should only put them in the ones where you truly are breaking because you can't handle every case. Okay? All right. Now, the last thing we have to do is just call this recursive version from here. And I'm going to call this one and get these tuple values a little differently. I'm not going to call it in the same way here. I'm not going to say let something equal. Instead, I'm going to say let a tuple, which has, let's say, result and remainder, equal evaluate. And I'm going to pass my whole op stack here. Okay? So this is a different way to call a function that returns a tuple. Here, you actually let a tuple equal the result. Instead of letting a single thing equal result and then using the dots to get it, you let the tuple equal it. And notice that these names don't have to be the same as these names. So result is the same, but here I use the word remainder instead of the word remaining ops. Okay? They do not have to be the same. And then here, we just return our result. Okay? So we learned a lot right there. Okay? We learned about tuples, passing, things back to tuples in different ways. How to ignore things in the enums and when we're getting associated values, all that stuff. So hopefully you got all that. I see a few people still kind of catching up on their typing, so I'll break for a second here. So that's it. That's the entire implementation of our calculator brain. It wasn't really that bad, actually, right? Pretty simple little data structure here. Just have to say what our known ops are. You have this recursion, which actually is quite simple, powerful code. If you're not comfortable with recursion, I can see how it might be a little bit disturbing, but go stare at it for a while and you'll get it, how it works. Okay? So now that we've got this new calculator brain, we have to use it in our old controller. Okay? Yeah, question, sorry. Do we have to let the op stack equal the remainder? Here you mean? Yeah. Well, we're not going to use remainder. So actually, even I could put I don't care here. I only put that remainder there to show you it could have a different name, but I'm not using the remainder. I only want the result. You see?
Won't the op stack contain what was previously in it before you evaluated?
Yes, the op stack will be unaffected by this because the op stack is an array. Arrays are passed by value, so a copy of it gets passed into here. So this would be untouched, and which is what I want. I don't want evaluate to consume my op stack. I want to be able to call evaluate over and over and over, okay? Especially if I, let's say, introduced variable operands. Hint, that's what your homework's going to be. Then I would want to change the variable to different things and be calling it over and over with different values for the variable, for example. And then maybe next week, I could have an assignment where I'm going to make you graph such a thing, which I'm going to do, okay? So that's why we want to do that. So anyway, yeah, remainder here can just be anything. I'm actually going to put this here because we're going to printlen this in a second just so we can get a better look at what's going on. But first, let's go back to our controller and use this calculator brain, this nice model we just invented. Let's use it. Now, I'm going to show you how to get two things on screen at the same time that aren't necessarily directly related. Before, we had the storyboard, and then I went up and clicked this assistant editor right here, and it showed me the controller because the assistant editor figured out, oh, if you have the storyboard up, you probably want the controller for the scene you have selected. But here it's like, oh, I don't know what to show you. So I'm going to show you a different way to get something in here. Well, two ways, actually. One is, if you go to this top bar, where it says counterparts, you can mouse down, and you can find all kinds of things about this, like subclasses of this class on the left, superclasses of this class on the left. Of course, it has no superclasses or subclasses. But other things it includes or included by it, you can also just manually go, and we could go over here, for example, and find our view controller and load it up that way. But I'm going to show you a different way than doing that, which is to go over here to your navigator. If you hold down Option and press on a file, like View Controller, it will appear on the right. Okay? So Option clicking in here is another good way to put things on the right. Okay? So now here we have our calculator brain on the left, and we have our controller on the right. We are going to rip out all of the stuff in our controller that had to do with being a calculator. Okay, so that's all this stuff right in here. Okay, all this calculating stuff. We don't need any of this because those were only called from there. Okay, so our controller is getting quite simple. Our controller hardly has anything left in it, and that's because the UI only needs this to be controlled. Okay, we also don't need our operand stack because the brain is going to do that. However, we do need a new instance variable here, which is the calculator brain. Okay, and I'm just going to create one like that. This is extremely common. Okay, this is the green arrow that goes from the controller to the model. Remember that in our MVC talk that I did last time, I said that the controller has a green arrow to the model. It can talk to it all at once, say anything at once. This is essentially that green arrow. This is our model right here, and this is the controller. This is how the controller talks to it through this thing we call brain. Okay, you can call it anything you want. And of course, this might be a much more complicated green arrow. It might be a network database that it's connecting to get the data. Okay, but in our case, it's this very simple little brain. Okay, so now we don't need this either down here. This is where we're appending onto the op stack and printing it out, so we don't need that. But we do need in enter to push the operand onto the stack. Okay, so here I'm just going to say that I'm just going to say brain.pushOperand our display value. Okay, that's the main thing I need to do is just do that. One thing though is I also need to update my display because when I push this operand, that's going to change the brain. I need to call that evaluate, right, and get the value. So I could call evaluate here, but actually I'm going to go back to my brain, and I'm going to change push operand to return the result of evaluating. Typing today. From internally, so I'm going to return evaluate here, so that every time you push an operand, it'll just return the evaluation. Now, one could argue whether this is the best thing to do, because you know, you might not be interested in the result of evaluating that right now, but it kind of feels to me kind of good, and it's not going to be, there's not going to be that many things on the stack. You're not going to usually have calculator brain have 1,000 operations and operands, although you could, but you're not usually going to, so it's probably not a performance issue to have it just return this. And it'll make caller's code, you know, look a little simpler. And if they don't want this return value, then they can just ignore it. They don't have to use it. But I am going to use it. So when I push this operand right here, I'm going to say, I'm going to if let the result equal that, okay, because it's an optional. And if it's not nil, then I'm going to set the display value to the result. So in other words, every time I push an operand, I'm going to up my display value with the evaluation. Make sense? Okay, what if this comes back nil? So I push something on. This is not going to happen probably with push operand, but it might. After your homework, it might. So what if I push it and it comes back nil? Well, now I'm kind of stuck. Okay? This is why in your homework assignment I suggested, wow, wouldn't it be cool if display value took an optional? Right? If display value took and returned an optional, you could put something sensible in the display when you had something that couldn't be evaluated. So in assignment 2, making display value into an optional is going to be a required task. So you might as well do it for homework 1, because you're going to have to do it for homework 2 anyway. Okay? Just wanted to give you more time because I didn't really teach you the things about number formatter and stuff in time for assignment 1, but it's going to be required. And that's because the best I can do here is maybe say display value equals 0. That's really lame, but that's the best I can do. I really want to say display value is nil. Okay? I really just want to set display value equal to the result of this. And I want to have nil, you know, clear out my display. Or in assignment 2, extra credit, maybe it puts an error message in my display. Now that's extra credit, but that would be even better things to put there. Okay? But same thing for performing the operation. Here's our operation right here. And I'm just going to say if I can let the result equal brain's perform operation of the operation that I got off the button, then I'm going to let my display value equal that result. Otherwise, I'm going to do the very lame thing of saying display value equals, value equals 0. Okay? People understand why that's kind of lame? All right? Okay. So that's it. Look at how simple our controller is here. It has almost no code in it. Okay? And that's really, iOS is great about that. It really is pretty good about making so you can build your UI mostly graphically so that there's very little code to control what's going on. And then even our model, which is a pretty powerful calculator right now, we could add as many functions as we wanted to it, just with one-liners here, and it would be capable of, you know, evaluating any series of them that's evaluatable. And it's also set up to do your homework, okay, which is to add those variables, to be able to push operands that are variables. The other thing your homework is going to ask you to do is to draw this, okay, the contents of it in a human-readable form, using infix notation like this, with parentheses when necessary, things like that. And that's going to be a lot easier here too, because you can use recursion to build this as well. Okay? So that's the main 2 things of your homework. That's what they are. All right. So let's see if we broke anything here. All right. So we're going to go up here and run. See if this all still works. Our UI has not changed. You notice I never even opened the storyboard here. Didn't even open the storyboard. Okay? All these changes were pushing things out of the controller into the model. Okay? The communication between the controller and the view has not changed here. So hopefully this is going to work. Let's try 85. Our number entering is still working in our controller. That's good. Enter. Okay, it still says 85. That's good. How about 41 plus? Oh, seems to actually be working. Square root. That's also working. 9 times. Excellent. That's working. Now, what if we do something that's not evaluatable? I'm going to press times a whole bunch of times, right? Times, oh, 0. See, that's not really great feedback, okay? But it's not really 0, but it's not good either. So your homework is going to be printing out what's on the stack in a nice form, so you'll be able to see that you have times, and it's going to equal a blank display, and that's going to make sense that it's blank. Okay. All right. Now, I want to do one.